The video sequences cover all the processes involved in making a body panel. The wing chosen for the exercise is an Austin Healey 3000 rear wing and is made from aluminium. This picture shows the wing standing upright, and the first job is to decide where the joint lines will be. The easiest way to work this out is to look at the panel, and wherever there seems to be a change in direction of shape is probably the best place to join the two panels. Because it is difficult to change a panel's direction or to put a high compound shape into it, it is easier to weld two panels together at the apex. Therefore, felt tip lines are drawn onto the old panel, dividing it up into sections, rather like a jigsaw. Knowing where to place these lines is not easily explained, but looking on the back of an old handmade panel will help the student to learn where the joint lines should go. The wing would also be too big to wheel up in one piece, so another joint line to divide the wing into a forwards and rearwards section is required. Before we start to make the panel, paper templates must first be made, following the shape and contours of the panel. As the template paper drapes over the panel, the joint line must be marked onto the template. The template should be stuck onto the panel temporarily, and the excess pieces cut off. The excess pieces are clearly seen being cut off. The template, partially cut out, it must be trimmed to the actual size of the panel. The template is now the actual size. The top template now being marked out. Again, for accuracy, the template is stuck onto the panel to stop it moving, and the felt tip dotted line is being drawn on. The template now trimmed to actual size. The top template now for the front half of the wing. Follow the same procedure as before. And the same again for the side template. The top template has now been stuck with masking tape onto the aluminium sheet and is then marked around with a felt tip pen. The felt tip image marked out on the aluminium sheet. The rest of the templates are now stuck onto the aluminium sheet, again to stop them from moving about. Draw around the templates with a felt tip pen. All the felt tip images can now be seen on the aluminium sheet. But these are the actual sizes, and in the interest of shaping and working the aluminium, the pieces must be cut out slightly bigger. An electric shear is the best device for cutting out the panels, as it keeps distortion to a minimum. When all the panels have been cut out, wheeling can then commence. A high raising wheel has been placed into the wheeling machine in preparation for wheeling. A wheel such as this would be used for high compound curves. The track marks left on the panel by the wheeling machine show the direction that the panel should be wheeled in. Wheeling near the edge to begin with will cause the panel to bend at the edges, taking the panel in the desired direction. The same panel viewed from underneath, clearly showing the wheel tracks following the shape of the outer edges. You must always wheel in the direction that the shape appears to be going. Therefore, in the early stages, it is important not to wheel in a straight line. A close-up picture of the hand-operated shrinker. This simple tool gathers up the slack metal at the edges of the panel and improves the ability to shape up compound curves. The panel has now been placed into the shrinker and is being shrunk around the edge. It sometimes helps to turn the panel over when shrinking. Always view the panel from different angles to make sure that enough of the desired shape is taking place. Wheeling more into the middle of the panel now, It is important not to neglect the other areas, as these would become troublesome flat spots later. It is always better to raise the shape of the panel equally throughout, even though some areas have to be wheeled more than others to gain the desired shape. Wheeling down to the arch now. All the shaping up so far has been with the high raising wheel to get the panel to shape up quickly. But any further wheeling at this stage with it would result in a panel of the wrong shape. So a middle raising wheel is now placed into the wheeling machine. This type of wheel produces a more gradual and gentle shape. Wheeling the panel now along its length and down the middle. This is to create a gentle curve over the whole length of the panel. Turning the panel sideways and wheeling from the middle out to the edge will increase the compound curve. This occurs by wheeling across the previous wheel tracks. Wheeling from the arch across the panel to the edge. Drawing the panel downwards towards the edge increases the compound curve and creates the most shape at the edges where it was previously shrunk. It may be necessary from time to time to re-shrink the edge and tighten it up to maintain the tension in the panel, which aids the raising up of the shape. Do not forget to wheel equally over the panel to avoid flat spots. Wheeling from the arch to the edge this time, further up the panel. Trying the wing for shape against the book or original panel. This can be done as often as required to make sure the correct shape is being produced. When the panel fits it perfectly with no gaps visible, then the correct shape has probably been attained. It is sometimes prudent to lay down the panel and check it for shape from different angles. Wheeling on the crown from centre out. Pulling down on the panel with short overlapping zigzag movements will stretch the panel locally, raising up the shape in this area. When the panel reaches the point where the shape is basically correct, it is probably time to swap the middle wheel for a smoothing up wheel. This has a gentle radius or low crowned surface and is used to remove any wheel tracks made by previous wheeling and also to even out the shape and remove low spots and irregularities. As can be seen, the wheel produces a blemish-free surface, taking this section of the panel up to the required shape and compound. Trying the panel for shape again against the book. This time a much better fit is achieved. The same panel from a different angle. For the time being, we have shaped up this panel to an acceptable level, but we must now leave it and move on to the other sections. We are now looking at the flat piece that will become the top half of the wing. This piece has a 3/4 of an inch extra edge which will be turned into the flange later. The panel is now wheeled along its length using the high raising wheel. It has been turned sideways on now. Wheeling across the previous tracks will increase the compound curve. The zigzag movements required to obtain the shape have been drawn on in felt tip pen. The edge of this panel is now being shrunk to draw the panel over to meet the main panel. This panel is also deceptive and actually curves sideways as well, so the outer edge opposite to the one that has been shrunk is stretched. This has been done using just the outer edge of the flat wheel. The finished piece being tried on the book for correct shape. When a perfect fit is achieved and no gaps are visible, then it has reached a point where it can be welded to the main panel. We now move on to the welding process. Aluminium welding can be tricky as the surface oxidises and impedes the flow of metal. The only way to avoid this is to remove the oxidisation from both edges to be welded. The best way to do this is with a file and a stainless steel wire brush. For best results, a flux paste is made up and applied to both edges with a modeller's paintbrush. The paste is actually made from powdered aluminium flux and a little bit of water mixed together. Both panels are now tacked together using oxyacetylene welding. I prefer to use a number 5 nozzle with the pressures turned down. This gives a large but soft flame, ideal since aluminium dissipates heat so well. When both panels have been fully welded together, the flux must be fully washed off using hot soapy water, otherwise it will start to corrode the metal. The weld is then hammered flat using a planishing hammer and a vice-mounted stake. The welded area is now wheeled to smooth the transition from one panel to the other. It also removes any high or low spots created by planishing the weld. Here we see some of the main simple tools required to shape aluminium. A bossing mallet, a flat-faced mallet, a wooden forming bat and a leather sandbag. Aluminium marks very easily, so it is always best to use wooden tools to create shape. The next piece to be made is the bottom section. Here the blank is being shown next to the wing. Using the smoothing up wheel, the panel is wheeled in the general shape. It must be added that there are not many completely flat panels found on cars, even though they may appear so. The flat wheel has now been placed into the wheeling machine and raised up on one side. This is required when turning an edge onto a panel. After marking a line onto the panel where the edge is to be folded, the panel is inserted into the wheel and tilted over to one side and firmly steered through. This results in a neat folded edge. Removing the panel from the wheel, a mallet and dolly are used to dress up the edge to the required angle. It may be necessary to shrink the edges a little bit to make the panel fit the book perfectly. With the main part of the wing placed back on the book, it will be necessary to overlap the bottom part of the panel and scribe a line. The excess material is then trimmed off. The bottom part of the panel will now fit flush with the main part of the wing. It is now ready for welding together. Follow the directions for welding as described before. With both components welded together, it is necessary to planish the weld to create a flush surface. We will now move on to make the two panels that form the front part of the wing. Pictured here is the blank to form the top piece. Using a bossing mallet and a sandbag, the panel is roughly shaped to the required contours. The edge, which will be welded to the side piece, is shrunk to bring it over to meet it. The panel is now wheeled to remove the mallet marks and raise up more shape. Check the panel against the book for the correct fit. Here we now see the blank for the side piece. Felt tip arrows now indicate the direction of wheeling. The desired shape is now visible. The panel has now been turned around. More felt tip arrows indicate similar directions of wheeling. A mallet and sandbag is used to create a hollow and accentuate the kicked up shape of the wing. The panel is now wheeled to remove the mallet marks and induce more shape. With the smoothing up wheel in place, the flat side is wheeled gently all over to put a slight compound shape onto it. Remember, there are no flat panels. The front and back pieces are offered up to the buck to check them for shape. Trim the excess off the top piece of the wing. Gripping both panels in place on the buck and with the side piece overlapping the top, scribe a line and trim off the excess. Remove the oxide with a wire brush in readiness for welding. The two sections are now tacked together and are then fully welded together. The weld must be thoroughly washed off with hot soapy water as mentioned before and then planished smooth. The finished welded area should be lightly filed. It may be necessary to re-wheel along the weld to smooth out any irregularities caused by welding or planishing. With both pieces gripped to the buck and overlapping each other, scribe a line and then trim off the excess. After welding the front and rear sections together, it will be necessary to smooth up the welded area. We can now turn our attentions to the flanged edge. It is necessary to anneal the edge of the panel to soften it sufficiently to turn the edge over. The edge of the flat wheel is kicked up to one side as described previously. The panel is pushed through firmly in a straight line at about 45 degrees. The edge is folded over gradually with repeated movements through the wheel. The flange will have to be hand planished to fold it over to the desired angle. It may be required to use the shrinker on the flange to rectify distortion caused in folding the flange over. This body panel has a swage line in it. Draw a felt tip line across the panel taking references from the book and then anneal the line. A hammer and a wooden drift are used initially to form the swage, but it is enhanced and finished off with the flat wheel. The final task is to fit a wired edge to the wheel arch. Using dividers, mark the required distance on the panel and anneal it. Turn the edge up with a hammer and dolly. Put the wire in place and hammer the edge over to fully enclose the wire. The wing is now complete and is shown alongside the original wing or book that it is being copied from. And finally, the completed Austin Healey 3000 rear wing.